Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
Hello. We will now start with a new topic, that is linked list. As we have discussed in the introduction part of data structures, that there are only two physical data structures are there. What are those two physical data structures? We have classified the data structures into two categories. One with respect to memory, another one with respect to access of elements. With respect to memory, there are two types of data structures, physical and logical. This data structure falls under physical data structure category. Another one, what we have already covered, array, also falls under physical data structure. Meaning for that physical data structure is memory allocation. So memory allocation is done only for either array or the nodes in the linked list, what we are having it over here. Other data structures like stack, queue, trees and graphs all are logical data structures. Logical in the sense there is no memory directly allocated for stack. There is no memory directly allocated for queue. Similarly for trees, for graphs also. If I want to implement, if at all I want to implement a stack, then either I have to implement it as an array or I have to implement it as a linked list. Then only I can allocate the memory in the memory structure. So it is something like this, linked list. Linked list is also called as chain. A linked list is a collection of nodes where each node consisting of either two parts, three parts, based upon what type of linked list we are implementing it. Basically, when we say a linked list is a collection of, I'll say, nodes connected together with the help of pointers. Each node basically stores the address of another node. Either if it is going to store the address of its next node or previous node, that defines the classification of linked list, whether it is singly linked list or doubly linked list or circular linked list, what type of linked list is. And the structure of the node also depends on what type of linked list we are using it. So in general, I can say it linked list is a chain or collection of nodes where each node stores the address of another node in the linked list. You can note down the definition, formal definition for linked list. A linked list is a collection of nodes. A linked list is a collection of nodes where each node stores the address of another node in the list. Where each node stores the address of another node in the list. Whenever there comes a concept like address, you need to have a pointer. Here also we are considering address, so we need a pointer variable. How many types of linked lists are there? First of all, singly linked list, doubly linked list, circular linked list. Singly linked list contains only one pointer variable. Doubly linked list contains two pointer variables. Circular linked list can be again implemented as a singly linked list or can be implemented as a doubly linked list as well. That means that a circular linked list, if it stores the address of the first node from the last node using one single pointer variable, it is a singly circular linked list. Similarly, A circular linked list can be doubly also. That means that I can implement a circular linked list using this one, or I can implement it using this one as well. We will come back to that particular concept later on. Let us start with the first one, that is singly linked list concept. Element 1 followed by element 2 followed by element 3, so on, element n, then null. Node structure for this particular one consisting of two parts. One is data part, another one is link part. Data part can be of any type of data. It can be integer data, it can be float data, it can be character data. Any type of data you can have it over here. Link is a pointer variable which stores the address of the next node in the list. Similarly, E2 is the data element, pointer, link stores the address of this node, so on, the next node address, so on, the last node consisting of data part and link part. Link over here for the last node is always going to be null. This particular part we are specifying it as null. Either you can say null or slash, or you can specify 0. Anything you can specify it over here. Programmatically, if you are doing it, you can specify with null or with 0. This slash is just for your usual representation, not for your programming purpose. For programming, either you have to specify null or you can specify 0. Node structure consisting of, every node structure consisting of two parts. Since it is only one pointer variable is included into this singly linked list, you call this one, the name is given as singly linked list, the name chain. In this chain we are having only one pointer variable, that's why it is a singly linked list. Now the address of the second node is stored in the first, address of the third node is stored in the second, address of the last node is stored in the second last. Then where is the address of the first node is stored? You must maintain always one variable, any name you can give it. We can call it with a name called as, say, first. I am calling this one as a first variable, or first is a pointer variable which is now going to store the address of the first node in the singly linked list. So on. Pointer, that is link, stores the address of second, link stores the address of the third, so on. The last one, since there is no node to be followed, either null, slash or 0 you can specify. All says it is null, nothing is there to be followed for this one. This is a general linked list, singly linked list. Either chain you can call it as. Then there comes a question, how do you define this particular part? Two programming languages, two ways you can define it. One way, parallelly I am doing for C language, parallelly I will be doing it for C++. Since there is a small difference in the implementation part when we come for implementation. Node structure consisting of two parts over here. So I will say now here structure. Name, you can give it any name. Say for example, I am giving it as node. You can give any name for this particular one. Two things it consists of. Data part can be of any type. Similarly, what we have seen earlier in sparse matrix notation, type can be any type, specific type this one is. So it's going to be have data. Link is a pointer variable which stores the address of the next node. So what we will do over here is, we will make this one as a pointer variable, say struct node asterisk link. How do you read this particular part? Link is a pointer variable which stores the address of a node which is already a structure. Complete the structure over here. Again, one thing to be noted over here is this one is a specific data type, not a generic one. You decide what type of data it should be, either integer data, float data, character data, whatever data it is. And link is a pointer variable storing the address of a structure node of the same type. That's why it's also called as self-referential structure. Why it is called as self-referential structure? Because there is a pointer variable storing the address of not other type of structure, of the same type of structure. It's pointing it to the of the same type. That's why it is called as self-referential structure. This one is a syntax for your C language. Coming into C++, templates can be used as a object-oriented concept template to implement any variable name you can use, class. There are two types of templates, class templates and function templates. Here, class templates we are using it. Node, instead of structure, class. Instead of type, we will be using it the variable whatever we have over here, data. Structure node, asterisk link. Here we will be saying it as node of template type star link. What is the basic difference now here is, first difference, there is no templates defined, one template is defined, such that specific data is used, here generic data is used. Advantage of generic data, you can pass this one t value from calling function by substituting either integer you want one time, next time you want float, you can pass float value, you can pass character value, any data type that is generic, same class definition, you can change the data type based upon your requirements. How do you read this particular one? Star link is a pointer variable which stores the address of a node which is not a normal node, it is a template node, you call this one as. So that's why you are specifying this node with a template. Here struct node, there is no template over here, here there is a template. And remember, struct is a keyword used here, there is no class name to be used inside the class. Structure, within the structure you are using it, need not use class followed by the class name. That are all the differences what you have between this programming language and this programming language. This is the structure of a node. Follow this one or follow this one. Can copy down this part. Okay. This is regarding general concepts of singly linked list. Then there are certain basic things we need to understand before performing some operations on singly linked list. Before going for any one of the problem or any operation on singly linked list, we will be seeing some basic concepts. How do you define a structure? How do you declare the pointer variable? How do you traverse the nodes in a singly linked list? How do you access the data elements? How do you access a link pointer variable? Some of the basic concepts we will see for linked list, then we will go for some problems. Let us assume that a singly linked list is of this particular one, say 40, 50, 35, 9, 20. Nothing is there to be followed, so I'll keep it that one as null. You know that first is a pointer variable which always points to the first node. How do you declare this pointer variable or any other pointer variable? With respect to programming languages C and C++, we will see it over here. Struct is the keyword, node is the name of this particular node structure. Then I'll say star variable name, what we have to declare it is first. I want to declare some more variable of the same type. I can specify it like this here, comma, star p, star q. There are three pointer variables I have declared. First is a pointer variable, p is a pointer variable, q is a pointer variable. All stores the address of node which is a structure type. When I declare that one, I want to allocate the memory. Even you can use class syntax also. I'm not specifying it over here. Class node. Okay. Then node type. Need not worry about the syntaxes of C++. Anyhow, if you want, I can specify both. Say C language memory allocation. How do you allocate the memory for a node in C language, and how do you allocate the memory for a node in C++ language? P, struct node asterisk malloc. I'll continue over here because the syntax continues. Malloc, then followed by size of the node. So I'll specify over here size of the structure node. I don't know the size of this particular one. If it is integer 2 bytes plus pointer always takes 2 bytes. That is fixed. For pointer 2 bytes of memory is fixed, but for this one it is variable. If it is integer 2 bytes, if it is float 4 bytes, like that it is going to be there. So 2 plus 2, we don't know what exactly the size is there. So malloc function allocates the memory based upon the size of the structure node, typecast it, stores the address into a pointer variable. Whenever this part is executed, you are now ready with one structure like this, where you know that every node, the name of this particular one is now node. We have already allocated the memory, but the address of this particular node, say assume that the address is some 200. So one pointer variable p is now ready, which is now currently storing the address 200, such that now it is pointing it to this, where you have two things to be stored in this node, data part and link part. How do you assign this part? How do you assign this part? And how do you access this particular value? This is one way of defining. Let us see another way of defining in C++. Same node structure, I can define it something like this. P is equals to new node of T. P currently storing the address allocated by this particular function. How much size, you know, this particular one. Here it is going to allocate the memory by new operator of node. You know, in node two things are there, that is data part and link part. P is a pointer variable. Again, P is now ready to point to a node. Both are same. So here malloc function is used, here new operator is used. How do you assign or access this particular part? You say P arrow data is equals to say 30. That means that I am now accessing the first part. P arrow, next part is link, is equals to null. So null is assigned. When node is created, memory address is now in P. Whenever I say P, it is 200. So P of data means 30, P of link means null. Three things are there here. P means only the address part. P of arrow data, that is you can read it as P of data. P of link, assign some value over here. These are how you assign the values, and you allocate the memory first, you assign the values. Same way you can do it over here. Memory allocation is done. You can access it using P of data, you can access it using P of link. Nothing change in that one. Same for C++ also. Now, how do you traverse a linked list? What do you mean by traversal? Traversing a linked list is moving from one node to another node. Like, for example, I want to start my traversal from this particular part, this node P. When we have allocated the memory allocation is done for P. You can assign the address of first node into P, or you can start the traversal from this particular one, because memory address is this, P is over here, one node is there. I want to assign first also to the same node 200, the same memory address. I want to give it to this first. I can give it something like this. First is equals to P. One pointer address can be assigned to another pointer variable. First is a pointer variable, P is also a pointer variable which we have declared it over here. So both are now pointing it to the same node. Assume that the linked list is now ready and P and first both are pointing it to the first node. I want to move to the next node. That means that move from this node to this node. That is nothing but traversing a linked list. How do you traverse a linked list? Is you say P assigns P arrow link. Simply, earlier the address where what is the address of P? P stores the address of 40 node. Now I want to change the address from 40 node address to 50 node address. So now if I assume some memory addresses are here, say 200 is the memory address for this node, 350 is the memory address for this node, 500 is the memory address for this node, 290 is the memory address of this node, 720 is the memory address of this particular node. Earlier P was storing 200, that's why it is pointing it to node 200. Now I want to change this address from 200 to 350. So where I should get 350? I am having 350 here in the part of link part of P. Link part of P is now currently 350. So here I can say 350 is stored, here it is 500 is stored, here it is 290 is stored, here it is 720 is stored. Actually memory addresses. Memory address are variable. As you allocate the memory, you get the memory address. You allocate the memory for this node, you get this memory address. Now first is also storing 200. P is also storing earlier 200, but once you assign, say P is equals to P arrow link, once it is executed, P is no more pointing it to 200, P is now pointing it to 350, because you say P arrow link. What is P arrow link? 350 is assigned to which variable? P. I want to traverse it continuously, one after the other. How long I should traverse? I should traverse from this part to this part, this part to this part. Like that I want to traverse until I reach the last node. Then you need a loop for doing so. I have while or for loop, any loop you can use it. While P, you can say, while P not equals to null, meaning for this particular one, P is if P is same as saying if P not equals to null. If P not equals to null. So here, while P not equals to null, I want to traverse. So this traversal code you can give it inside. You can say P assigns P arrow link. This is how you can traverse it within the loop. Instead of giving it here, I'll not give it outside. I'll start the loop, but where should P starts from? I'll say P takes the address of first variable. Then first and P both are pointing it to the same. When it enters it, it traverses it for the first time, goes to the next node. How long it continues? Until it reaches null value. First time traversal, second time traversal, third time traversal. How long? It's going to have last part. When we assign P arrow link part to P, last time when you see link part is null, when you assign null to P, when the condition is checked, the condition satisfies and it terminates the while loop. So single traversal is only one line traversal. P assigns P arrow link, one time traversal. In a loop, continuously you want to traverse until you reach the last node. You can use any one of the loop, either for loop or while loop. You can traverse it and perform any one of the operation. Like this one is very useful in performing insertion of a node, deletion of a node, finding the node, finding the value, or finding the node, searching a node. There are many operations. Without traversals, you cannot perform any operations on a linked list. So the most important operation I can say on a singly linked list is a traversal. Basics among this one is allocating the memory, accessing it, data part, null part, assigning the address of one pointer variable to another pointer variable, traversing a linked list one step, or continuously within a loop you can access it. Giving it this one is same as giving it this particular condition. These are some of the basics required for understanding the concepts of linked list. Please make a note of this one. If I assume that P is currently here and first is currently here, I want to print some value, as I say, P of link of link of link of data. What will be outputted for this printf? When P is pointing it to this node and I am trying to print P of link of link of link of data. What will be outputted? P means currently this address. Address of this node is 200. I am talking about 200. Of link, that means this node I am talking about. One time link. Second time link of this node. Third time link, that means of this particular node I am talking about. Of data means what is printed now is 9. Is it clear? So you can give any number of times the addresses P arrow link, arrow link, arrow link. One more arrow link if I give, it will now point it to the next node. Then if I try to print the data, 20 will be printed. Okay. Based upon this particular concept, there is one problem. Note down the question. What is the output of the following operations? What is the output of the following operations performed on the given linked list? A to E is the linked list given. These are the sequence of operations which are given as and the last operation that is carried out is printing of data. Directly I am not giving percentile D what we have given. Directly I will print the data over here. Assume that print percentile D is used. 1, 2, 3 times link is used. Then data is printed like the same print. What will be outputted? Can you just have this output? Try to work out on this one. Take 1 minute time and try to print the output. F here stands for first. Like we have a first pointer variable, F is a pointer variable here. So we assume that for this one, F is always now starting with here, F. Let us see, for those who have done, for those who have not done, we will compare this particular two things. P assigns f of link. F is here, of link. Currently P is here. P of link assigns P address. That means what you will give it over here. When I say currently P is currently this particular part. P of link means this particular part. Its link. I am giving the address of P. This part, D link. Then you say f of link also changes to P of link. Currently P is now pointing it to C. Its link is now again changed. That means that in f of link, what you will give? You give the link of P. What is link of P? Is this one. So currently this link will go on and this link will be created. Now you are trying to print something like f is now currently pointing it to this particular node. Then you say f of link 3 times. When you start from this particular one, f of link 3 times. When I am saying of data, then what is printed over here is D part. I'll repeat once again. Initially, when we start the process, f is the only pointer variable which is now pointing to the first node. First step, execution, takes P to point it to node C, because we have two links to be there. When I say f of link, I am pointing it to B, its link pointing it to C. So first step makes P to point it over here. First step over. Second step, P now takes the address. P is currently pointing it to C. So that P address, is assigned into P of link. Currently when I say P, it is C. P of link means this particular part, the address of D. In its link, that means that this link is to be changed 2 times links, that this link takes the address of what node? P. P is C address. So this link is gone. This link is created based upon the execution of second step. So P address is assigned to the link part of P. That is nothing but link part of D actually. So your first step execution is this one. Second step execution is this, a link is created. Third step execution is currently P is pointing it to C. Its link is what? D. That address, D address, where you are giving it to f of link. Currently f of f is this node, f of data is this part, f of link is address of B. When you are assigning the address of D, this address is gone, and the third step execution, this line pointer will be created. P arrow link address is given to f arrow link. Third step execution. Now you are trying to print f of link. Your f is here currently. When you say f of link, earlier you are pointing it to B. Now when you say f of link for the first time, you are pointing it to D now. First link is over when you reached D. Then again second link is over when you reached C. When you say one more link, you again come back to D only, because there is a pointer from C to D. So which completes the second list. When you reach this particular part, data part over here is printed value is D. Hope this part is clear. The execution of all the 4 steps can copy it on this. Tracing is very important. Very important part in programming language is tracing. How do you trace the steps? Let it be singly linked list, let it be doubly linked list, let it be any program on stack, queue, anything, traversal of a tree or traversal of a graph. You need to perform a very good tracing part. So absolutely you must be very clear that first step what it is doing, second step what it is doing, third step what it is doing. This makes you to solve any complicated problem. You can solve anything by tracing out this particular one. So I'll just make out this one is tracing part. Very, very important over here. Note down the tracing part. Hope you are done with this. Operations on singly linked list. Like we have seen operations on linear list. If you remember, I'll just recall those operations on singly linked list as: first operation, creating a linear list, inserting an element at any given kth position, deleting an element from any kth position, finding an element at any given kth position, searching for an element in a linear list, finding whether the list is full or not, finding whether the list is empty or not, finding the length of the list, and last, displaying the contents or the data elements of the list. Same operations can be implemented for singly linked list as well. Apart from that one, apart from these common operations, there are certain important operations are there on singly linked list, which are something like this: printing the data elements in forward direction, printing the data elements in reverse direction. For a singly linked list I am talking about. For singly linked list, only direction is there in forward one. You can access the data in only forward direction, but you need to perform the operation as printing the data elements in both the directions, from first node till the last node. Similarly, from last node till the first node. This is printing of data. Coming into counting exactly how many number of nodes are there. That is, your length is there, you can count it. Count the number of occurrences. Say for example, 50 is the data element appearing more than once in a singly linked list. Then you need to identify how many times that 50 is appearing. Make a count of that occurrences basically. Find out 50 occurs how many number of times. Then you have the remaining operations. We will see it one by one. First one we will start up with. Creating is already done. Second one, insert the element at a given position or any kth position, delete from kth position, finding the element at a given kth position, search for an element and find whether the list is full or not, find whether the list is empty or not. Length, finding the total number of elements in the list, and displaying are the usual operations what we carry out on a linear list. Same thing can be applied for a linked list also. There is a difference between linked list and linear list. A linear list is just a collection of data elements basically, not connected together, whereas a linked list is a collection of nodes connected together with the help of one pointer variable. So same thing we are applying it over here, basic operations, then we will move on to some advanced operations as well. Let us say creation of linked list is already done. Memory allocation, malloc function, new operator. Whenever malloc function is used to allocate the memory, you need to perform deallocation of memory also. So deallocate function can also be called. You can release the memory with free function, or you can call delete operator when C++ is used. For C function, it is going to be free for deallocation if it is allocated with malloc. If it is allocated using new operator, then you can have, this is for C++, this is for C language. Malloc function is used, free. New operator is used, delete. Creation of node is very simple. The memory allocation, once it is done, then memory is there until the program terminates. Coming into this particular operation, that is insert. Let us start with the first operation, insert. Inserting an element, say I am calling this particular one as X element at any given kth position. What are the possible valid positions I can insert it? Say for example, I have already one singly linked list available. Very simple singly linked list we will consider. Say 20, 30, 40, 50. Last node null, first node say first. How many possible valid positions I can insert a node? Like in array also we have seen how many valid positions we can insert it. If at all user enters any invalid positions, we will say no, it is not a valid position, we return to the calling function. Here there are 4 nodes. You tell me how many possible valid positions are there. First position means a node before 20 is a valid position. Second position is between 20 and 30 is also a valid position. Similarly, third position, similarly fourth position, similarly fifth position after 50 is also a valid position. So right now there are 5 valid positions, but is it going to always be 5 valid positions? No. If the number of nodes increases, again the valid number of positions also increases. As the number of nodes decreases, the number of valid positions also changes or decreases. What we should do is, we should generalize this number of positions into these categories. How do you classify this one is, first part, first position, I'll say k is equals to 1. I'll specify this one always first position. Let it be 1 node, let it be 3 nodes, let it be 30 nodes, any number of nodes are there. First position code, source code will be same. Similarly, last position, that is k is equals to, if at all, how many number of nodes are currently here? 5. 4. 4 nodes are there, 5 valid positions. So anything for length plus 1 position, fifth position is the last position, generalizing this particular one, last position. Then middle position can be anything. K middle position can be any position between first node and the last node, like second position, third position, fourth position, can be any k middle position. If we categorize this one into 3 classes, then the insertion of this particular node will be very easy. Okay, let us start with this first one. First case, first position I want to insert. What would be the simple operation to carry out on first position? I'll just draw a node over here. You know that memory allocation is done. I'll just allocate the memory one more time over here for your convenience. P, I'll declare a pointer variable struct node asterisk p, then p is equals to struct node asterisk, that is typecasting malloc function, followed by size of operator, which we have already seen, struct node. P is now ready with this structure, pointing it over here. Okay, P is now currently allocating the memory. So I'll assume that similarly first is a pointer variable, first is now pointing it to always this node. So instead of saying P, P is a pointer variable. Memory is allocated for either first or for P. You can. Now that I want to assign this node, I want to insert a node into first position. First position is before 20. Simple operation is whatever be the node that is allocated the memory is P. You know how to assign data part, P arrow data, you give it this particular part. You have data part over here, that is X coming into picture. Let us say the value of X is 50. So 50 is already there, so I'll take another value over here, say 60. 60 is the data part. Link part, initially I'll make it null. This node has to be attached to this linked list, existing linked list. What is the simple operation is remove this null part, assign a link like this. Is the node attached to the existing linked list? Yes. But is the job done? No, it is not fully done. That means that when we have inserted 60 into its first position, your first node is now 60, not 20. First node is 60 rather than 20. What is the next job to be done is remove first from here and place first here. Once you are done with this one, insertion of a node at first position is done. What would be the possible code you need to follow it? You know that memory allocation is done, data part is also done. I'm not worrying about this particular part, assigning data part to this P. So we have already came across this one, P arrow data. One time I'll do this job again. P arrow link will take null. So one time job. Then P is now ready to point it to the next node. What is the pointer we have changed? Is the first one is this pointer. Earlier it was null. Now it is going to point it to this node. What is this node is referred as? This node is referred with a pointer variable called as first. So you say P arrow link takes the address of first node in the linked list. First is now pointing it to 20. P is also now pointing it to 20. With this statement executed, first assigns the address into P arrow link. This link is created, but the job is not fully done. So what you will do now is remove first from here, place the first pointer to point it to same pointer variable P. So what you will do now is you say first is equals to P. Assigns. Like we have seen, we can assign the address of one node to another node. In the example we have seen here, first assigns P means one pointer address can be assigned to another pointer address. Same thing we are doing it. This pointer address is now stored in first such that this node becomes the first node. Is this code applicable for first position? Same way, I want to insert a node into last position and middle position. How to do this particular thing is, for inserting a node into either last position or middle position, two things we need to perform traversal. Unless and until we move on to that particular position, we cannot perform insertion. Okay, so you first note down this part. generalizing the insertion process into three categories. Then take this example linked list where first is already pointing it to 20. Now first is pointing it to this node 60 after inserting a node 60. This is the source code for either C program or C++ program. It will work. Just copy down these contents, then we will see the traversal for the next two techniques, that is two cases. Hope you have done with this first position. We have to perform traversal. For performing this k is equals to length plus 1, that is the last position or any middle position. You know that traversal is always done with single traversal, P assigns P arrow link. If at all you want to perform it continuously within the loop, we will see it within the loop. We will be having it using either while loop or for loop. For time being, we have already seen this particular part. We will continue the next part. Okay.